Hello again, folks. Now we're going to learn about today linear inequalities. So our content objectives are you'll be able to graph linear inequalities and then write and use linear inequalities when modeling real-world situations. Other objectives is you'll be able to define linear inequalities and solutions of inequality. Okay, first thing I want you to do on your note sheet is cross off this first one. It's poorly written and it's not. I forgot to delete it from the slide. It's not a good example. So we're going to start here, and we're going to look at. It says tell whether the ordered pair is a solution to the inequality. Okay, so here's our inequality. Y is less than 2x plus 1. So what I'm going to do is I'm going to take my x value and my y value and plug them in. So if you look here, I took the y or the 4, put it where y is, and I took the negative 2 and put it where x is. So now I'm just going to solve this. 2 multiplied to negative 2 is negative 4, plus my 1 is negative 3. And I'll bring down this, and I'll bring down this, and now I have to make a judgment call. Is 4 less than negative 3? Is 4 less than negative 3? And no, it's not. So I would say no, and that's what you're going to be asked to do. You're going to be asked to take a value, substitute it in, and see if it makes the inequality a true or a false statement. And if it's false, write no, it does not work. This is a handy chart for what we're going to be doing next. Step 1, solve the inequality for y. In other words, get y by itself, slope-intercept form. Next, graph the boundary line. Use a solid line for less than or equal to or greater than or equal to. So I'll talk about that. So these will be solid. Okay, you might want to write that in. And use a dashed line, okay, dashed if it's just less than or just greater than. Last step, shade the half of the plane above the line if y is greater than or equal to. Shade the half below the line if it's less than or equal to. I'll show you what that looks like. Check your answer. It's also a very important thing. If you don't understand the shade above, shade below, you can also check your answer to see which part you shade. Here's our first example to graph. So it's just like graphing a linear equation. It's in slope-intercept form, so I'm going to start at negative 3, 1, 2, 3, and make a dot. Then I'm going to apply my slope, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so that's the first part. Now I look at this, and it says less than or equal to. Remember, because it's equal to, it will be a solid line. I need to make a solid line. So I'll do that. I'll go like this and make it solid. All right, I'm almost done. It does say y is less than or equal to. So you put your pencil on the y and have it the y-intercept. If it says less than, then go below the line. Go below. So here's what I'm going to do. I'm going to shade the area below the line. So anything in this shaded in area will be an answer that works in this inequality. And it says to check a point. Okay, and that's important. So I'm going to check a point. I'm going to check, how about right here? So that would be 1, 2, 3, 4, negative 2. So 4, negative 2. I'm just going to check that really quick. So I'm going to take the 4 and put it right there. So 2 multiplied to 4 is 8. 8 minus 3 is 5. Is 5 greater than or equal to negative 2? Is 5 greater than or equal to negative 2? Well, yes, it is. So I checked it, and it worked. That's an important piece if you want to make sure you're 100% right on your shading. this is just a handy slide to remind you about the things I pointed out before. I like it because it's visual. This shows you a solid line means that it had an equal to sign on it. The shading, because it's green up here, it means that it was y is greater than or equal to. In this case, it would be this one because the line's solid. If it's dashed, there is no equal to underneath. And if you shade below your line, that means it was a less than or equal to. Alright, we're going to graph to see the solutions for this linear inequality. First thing is we need to get y by itself. Now, a lot of us would move the 4x and the 2 to this side. I'm not going to do that. I'm going to move the y. It's a minus y, so I am just going to add y to both sides. And when I do that, I get 4x plus 2 is less than or equal to y. Another way I could write that is y is greater than or equal to 4x plus 2. Please notice the y is being eaten by the monster. The y is being eaten by the monster. So it's the same thing, just written a little differently. But this is the same inequality. So now let's graph this. Start at 2, so 1, 2, make a dot, and then go up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And 1, 2, 3, 4. We can apply it the other way. I'm making my line with a solid line. See if you can tell why. Okay, hopefully you did. It's a solid line because there's an equal to sign underneath the greater than sign. So I'm almost done. It is y is greater than, so it's important to have the y on the left so you read this correctly. Y is greater than or equal to. So greater than means I start on my y-intercept, and greater than means go above. So I start to shade above, and I just keep going. I keep going. Let's check a quick point. I'm going to check right there, right here. I'll check negative 1, 1. So I'm going to put a little dot there and check. Negative 1, 1. So let's check that quickly. I'll take the negative 1 and I'm going to put it right here. So I'm going to do 4 multiplied to negative 1 minus, then my y value is 1 plus 2 is greater than or equal to 0. So let's check that. 4 multiplied to negative 1 is negative 4, and negative 4 minus 1 is negative 5. Negative 5 plus 2 is negative 3. So is negative 3 less than or equal to 0? And I would say yes, negative 3 is less than 0. So this one worked. We did it correctly. Alright, in this example, first I need to get y by itself. So I'm going to minus 4x from both sides. And it'll look like this. Negative 3y is greater than negative 4x because I minused it, plus 12. Now, remember inequalities. I'm going to divide both sides by negative 3. Woo, 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 woo. Okay, remember, if you divide by a negative, you've got to flip this. You've got to flip it. So don't forget. It looks like this. This becomes y, and this becomes less than instead of greater than. And then my slope becomes positive 4 over 3. And then my y-intercept becomes negative 4 or minus 4. Now I am ready to graph. So I'm going to start at negative 4. 1, 2, 3, 4. I'm going to make a dot. And then I'm going to go up 4 over 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Now, I notice that it says less than, and there is not an equal to sign. So, this needs to be a dashed line. And that tells the person that if you include a number that is on this line, it will not count. It won't work. It's not okay. I forgot to talk about that before. Before, I could have picked a number on the line because it was solid. That would have been fine. But now when it's dashed, I cannot pick a number that's actually on the line. It says y is less than. So less than means below. So I'm going to shade below, and I'm going to pick a number in this shaded area. So let's just pick a number. How about we do 1, 2, 3, 4, -1. So I'm going to do 4, -1. 4, -1. So I'm going to plug that in. So I plugged in the 4 to the x and the -1 to the y into this inequality, and I'm going to check it. This is 16. This is positive 3. Is 16 plus 3 greater than 12? Yes, it is. It's 19. So it worked. We have a few slides of practice problems, so sorry about that. I just wanted to give you enough room to do all your work. So on these, tell whether the pair is an order. Tell whether this ordered pair would be a solution to the inequality. So find out if it's true or false. Here we have one. Y is by itself, so graph it and make sure you decide if it's solid or dashed, and make sure you shade in the correct spot, and then check to see if you're right. This is another practice problem to see if you're able to graph. I would get y by itself first and then graph the inequality and remember to shade.